Okay, let's go. It's gonna be hard. Minimum operations to make array elements 0. Be given a 2D array queries where queries of I is of form left comma right. Each query's eyes defines an array of integers. Defines an array of integer nums consisting of elements ranging from L to R inclusive. In one operation, you can select two integers A, B from the array. Replace them with floor of A divided by 4 and floor of B divided by 4. Your task is to determine the minimum number of operations required to reduce all elements in the array to 0 for each query. Return the sum of the results for all queries. The sum of the results. Okay. So the queries are 1, 3, and 1, 2, and 2, 4. So for queries 0, initial array is 1, 2, the number of operations. First operation, select 1 and 2. The array becomes 0, 0. So 1 becomes 1 divided by 4 is 0, 4 is that 0. So the minimum operations, okay, and then 2, 4 implies that there's an array that is 2, 2, 3, 4. So I think you need two operations here. Like if you do 2, 4, that makes this 0, that makes this 1. And then 3, 1, that makes both 0. So 1 plus, so 1 operation for the first query, 2 operations for the second query. So that's total 3. This doesn't seem like a hard one, I don't think, actually. Could be wrong. So each query could be, if I take the problem as a single query rather than a list of queries, I think it should be done in pretty fast time. It's not going to be quadratic. It's probably going to be, it should probably be linear, I'd say. So linear, I see. If it's linear time, it's linear with respect to the length of the query, implied length of the query. As I currently understand it, it has to be faster than that. It has to be constant, maybe. More logarithmic. Yeah, so each query can't take n. If a query has is like 1 through n, it can't take linear with that length. Otherwise it would be quadratic overall because you have n queries. And that's just too slow. So it has to be faster. Then you can't just go through like a for loop that goes through indices from L to R, values from L to R. Okay. So let's think about this. So if I have L to R, so based on parameters for based on constraint parameters. the overall speed of evaluating each query must be faster than n in order for this to work. So, for example, if a query is, let's say, 1 to k, must be able to determine number of operations faster than OK. Okay. So how to determine? So let's say I have a query that is 100 to 1,000. How many operations are necessary without using loop? It has to be exactly. So 100 goes down to 25, 6, 1, 0, including the flooring of the division by 4. So the breakpoints there would be, so the breakpoints, like where it's like between values. So breakpoints would be 0. So powers of 4 I think are going to be next to the breakpoints. So 1, 4, 16, 64, 256. So if it was slightly, if it's above the breakpoints, 6 still goes to 1, 15, just 15 still goes to 1. How does this breakpoint work? So if it's 3, it still goes, 4 goes to 1, so 3 goes to 0. Anything below 3 goes to 0. 3, 2, 1 goes to 0. And 15 through 4. 15 goes to like 3, right? 15. Yeah, so 15 through 4 goes to 3 to 1, which eventually goes to 0. So 4 takes 2 turns to go to 0. 15 takes 2 operations to go to 0. So that means it's like 63 to 16 goes 15 to 4. So that takes 3 operations. And then 255 to 64 goes to 63 to 16. So this is like, in this range is one operation. In this range is two operations. This range is three operations. And so on. So the power, so this is 4 to the third, 4 to the second. So if it's, let's say, 4 to the power of n minus 1, through 4 to the power of, actually, power of n plus 1 minus 1. 4 to the power of n plus 1 subtracted by 1 through 4 to the power of n takes n plus 1 operations to become 0. So if n is 1, which means this would be 4 to the second minus 1, which is 16, minus 1, which is 15 through 4. 15 through 4 takes 2 operations. Okay. So then the question is, like, how many of these numbers fall into each bucket? So if I had 100 to 1,000, the powers of 4 that are within that range is 256. And that's it, right? 256 times 4 is going to be 1,024. So 100 to 1,000, that range becomes 100 to 256. I'm not sure if that's, yes, 100 to 255, and 256 to 1,000. Maybe I should use the union symbol. And then 100 to 255, that's all in the same bucket. That's going to be in the 4 bucket. So that's going to be 4 operations times however many values. 255 minus 100 is 155 plus 1 for inclusive endings, so it's 156. And then the other bucket is 5 operations times, well, let's see, 1,000 minus 250 is 750, minus 6 is 744, plus 1 is 745. Is that right? I think that's right. So that should be 4 times 256 plus 5 times 745, 4349. Gosh darn it. Okay, so I'm off by like an order of magnitude, kind of. Oh, that's, yeah, I'm thinking about this wrong. Because each operation takes 2 numbers, right? So 4349. Well, and then each operation takes 2, so you divide that by 2. and then round up probably. Like the ceiling this. Round up this is going to be 2175. 2175. Okay. So I need to know for the query the relevant powers of 4 that are within that query and how many of them are there. It's the count of the values for each bucket. Okay. Wonder if I can sort the queries to make this more, if that's helpful. That's interesting. There's a meta-analysis of the queries themselves. I could sort the queries and then combine the ranges maybe. I don't know if that's any faster though. I still have to identify powers. I can take the log base 4 of each number to identify the lower bound power of 4 and the upper bound power of 4. Does that make sense? That should be pretty constant. Number of queries. It can't hurt to sort the queries. In which case, if I sort the queries, I don't have to do more of a iterative compare to certain breakpoints, compare to certain powers, and then know that the next one is going to be at least that much, so maybe more if statements than log computations. Okay, I just gotta go through the math. I always attempt to go through the math. 4 left. I'm not sure if I want to use left and right. I can use low and high. And the queries. So for each low and high value in the queries, I need to identify the power 4 that would be the lowest power 4. That might be in the range values. And the highest power 4 that's in the range of values. So I think it would be something like, okay, let me go ahead and just create a static array of power 4. So the query themselves can go to 10 to the 9th. Let's say powers is an array that starts with 1, while 4 to 0 is 1. Right? So while powers the last value is still less than 10 to the 9th. Powers append last power times 4. I'm going to just print out powers. Make sure that's working. Error is not valid for expected return type. Turn powers outs. I want to print powers. Okay, those are the biggest powers for 4. Okay. So for every low high in queries, so I want the low power is going to be the lowest power 4 that's inclusive in the range. So that should be log, gosh, what is Python log? Log base Python. I think it's log with 2 parameters and in the base, x base. Hopefully this works, because it can have some funky loading stuff. So log of the low value base is 4. So if it takes 4, log of 4 base 4 is going to be 1. No. Yeah, 1. Okay. I want this to round up. I think I want this to be the ceiling. Is that the right thing? Math.ceiling. Or seal. Okay. So that should give me the index into the array. So it should probably be powers of this. And I guess I can try to print this. Print the low and the low power. So 1, the lowest power 4. Is that what I wanted? 1? Yeah, it needs to be at least the value of that thing. And then 2. Actually, is that what I want? 1 is in the range of 2. How do I want to treat the 1? I want to treat it as I want to treat the 1 as in the bucket between 3 and 1, which has 1 operation. So if I have a range that is 1 to 2, 1 and 2 are both in that bucket. So I don't 1 or 2 both in that bucket. So I think it's gonna work. So I think it should be low plus 1 here, because I want to treat 1 as in the next bucket. And yeah, I think this should be low plus 1. Okay. So 1 is in the bucket that is up to 4. I don't know about that. No, this cannot be how I should do it. So the low power should be the lowest power 4 that is inclusive within the range of values. And the high power should be the lowest power 4 that is the highest power 4 that's inclusive in that range. Change this. Powers. The ceiling is going to be ceiling. It's floor. Also floor. I think it's called floor in Python. Round down. The floor of log of the high power, the high value. Base 4. Okay. I'll have to deal with the breakpoints separately, but I just want quick powers. Okay, so 1, 2. The lowest power 4 that fits in there is 1. Highest power 4 that fits in there is 2. 2, 4, same deal. 4 is the biggest power 4. 4 is the smallest power 4. Okay, and then if it was something more complicated, like that crosses multiple powers of 4, let's say it's 10 to 100. So it'd be 16 to 56 is what I'm expecting. Okay. Alright. Alright, so I think the next step is to, if there's a full bucket, so the high and low buckets, the buckets at the end of the query range are possibly not full, but anything that is in the middle buckets has a full number of operations required. And that should be static. That should be pre-calculated. So assuming I have a full bucket for certain ranges of certain range of values between the powers of 4, then I'm going to calculate how many operations it should take. Or basically half operations, where each operation actually does 2 floors and just taking account of 1 floor. So it's going to be done for every index in the range of the length of powers. Yeah, powers minus 1. Let's say count of values is going to be powers of index plus 1 minus powers of index minus 1, or is it plus 1? I guess it's minus that. So if it's so if you're dealing with, actually, can a query be 0? Okay, query can't. The value range is not 0. So if it's 4 minus 1, then it gives you a range of 3. 1, 2, 3. If it's 16 minus 4, it gives you a range of 12. which I think is correct. 4, 5, 6, 8. Yeah, okay. And then each of those values will have the same number of operations, and that number of operations is equal to the power of the first. That's minus. So this is one operation. So index is 0. Index is 0. There's one operation, so index plus 1. So full ops is going to be, I think, an empty array. This gives me an array for the number of operations to number of floors. I want to be secure, because each operation actually does 2 floors. Number of floors to 0 out number of those to 0 out values in 0 all values range from 4 to the x and 4 to the xmas. 4 to the x plus 1 minus 1. A in range values for in range of values between powers of 4. In range of values for bucket. Range of value buckets that are, I'm not sure how to describe that. Count. And you do count full ops append count times index plus 1. And I'm going to print out the full ops to make sure that seems to be okay. So the first one has 3 values. Each one takes 1 operation, so it's 3. And the second one should have 12 values, 16 minus 4. 12 times 2 is 24. Next one should have 48. 48 times 3 is 144. Okay, that's right. Okay. I think these are probably fine. So for each low and high power in the queries, this feels like it could be further optimized. Yeah, I think I don't want to do a summation of every bucket that's full between the low and high. So I think I want to use a prefix sum here as well. Yeah, prefix sum to quickly sum of the values of buckets. So I'll do prefix sum of a full ops array. I saw a hint, or I saw a version of the prefix sum is actually that uses 0 as the last appending 0 rather than starting with 0. I think I'll do that. So how to set this up? Let's say total is equal to 0 for every index, for every value in the full ops prefix dot append total plus equals value prefix appends the total, and then lastly prefix appends 0. That should work. Yeah. This is horrible commenting. Probably want to use inline comment here. Ours are for the our breakpoints for number of for x. Need to 0. Okay, so low high queries. So I need to, for a particular query, need to identify the side amounts that might not have full buckets. Calculate the operations for that, or the half operations for that. Okay. So low bucket. It's gonna be it's gonna be the count of things from the low value to the low pow minus 1. The low value to the low pow minus 1. In theory, it could be that could be 0 because low pow minus 1 could actually be could actually be below low. So the low bucket is 0. It's probably within the formula actually. It's the number of values, so it's the difference between them minus 1 probably. The low pow minus the low value, so it could be like 1 minus 1. No, it's actually equal, right? If it's 1, yeah, I think it's actually equal. Low pow minus low. If low pow is 1 and the low value is 1, then there's nothing in the 0 bucket. Yeah. So, and the high bucket should be the high minus the high pow. Is that right? No. Actually, maybe. Stop printing out the high pow and the low pow. So if the bucket is 6, so here the high pow should be 4. So it would give you 6 minus 4, which gives you 6 minus 4, which gives you 2. It actually should be 3 because it's 6, 5, 4. So this one should be plus 1. The low pow here should be 4 minus 2, which is 2. 2, 3. 2, 3 is correct. Yeah, so I think this is right. There has to be plus 1 at some point, otherwise it's not going to be inclusive of both the low and the high in the query. So it's inclusive of the high one. Okay. And then I think this makes the low bucket, so that's the count of the values in the low bucket. I think I need to know the indices actually. I'll call the powers A and B, I guess. A equals log of low comma 4, the ceiling of it. And B is going to be the floor log of high 4. So this is going to be A and this is going to be B. And I think A is going to give you the same number of half operations as you would need for everything in the low bucket, I think. So I should have a count here, count 0, half operations, number of half ops, or number of before of x divided by 4. So this should be count plus equals low bucket times the low pow, I think. So if the low pow is 1, the low bucket The low power is, I'll say the low power is 2. No, the low power here is 1. Or A here is 1, which is the actual power, and then low power value is going to be 4. And the low bucket, which has 2 and 3, each takes 1 operations. So yeah, each takes 1 operation. And the high bucket, or the count for the high bucket, is going to be, I think it should be high pow plus 1, I want to say. And then the stuff that is the full buckets between them, which should be differentiated by the difference between A and B, are the full buckets. Or A and B are the indices for the full buckets. Or the indices were yeah. So this should be, count should be adding the prefix of B minus the prefix of A. Which would give you 0 if they're the same spot. But let's say they're not the same spot. So here it's here 16, which has the A value of 2, 16 which has an A value of 2, and 256 which has an A value of 4, 2, so 0, 1, 2, so 144, that doesn't seem right. Maybe it is. 3. Seems like it might be off just a little bit. But let's go ahead and just try it out here. Answer plus equals and ceiling. Or I guess I can just round up, so count plus 1 divided by 2. So this could be slightly off. I forgot to return the answer. Okay. Yep. This should be maybe B minus 1, A minus 1 is my sense of it. Or this could just be very off. It's just very off. Okay. Let's go ahead and do some printouts here. Print A and B. Let's go ahead and print the low bucket, the high bucket, and I guess the count. Okay, so the first 1016 was low and low pow. Next one was 1256. That's a huge count. Oof. Low bucket, high bucket. Those seem pretty reasonable. That does not seem reasonable. Prefix b minus 1 minus prefix seems really off. Do, 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 do. Okay, for the operations, 3, those seem fine-ish. Okay, so why is it that, so if I have prefix 2 and 4, 0, 1, 2, 4, it should be subtracting this thing by this thing. I think. Prefix of b minus 1. It's actually doing b minus 1. Prefix b minus 1. So it should be doing something even smaller, like 0, 1, 2, 3, 4 should be 939 minus 3. Pretty sure this is actually minus a. Count plus equals that. So this thing is the high bucket times high power plus 1 giving it a huge number. High bucket times high. Like if I don't have the minus 1s, it makes it even larger. There's something wrong. Well, obviously there's something wrong, but these numbers seem unusually high. Low bucket times low pow or low pow. It's supposed to be times A and times B. Times A times B plus 1. God damn, that's so stupid. Okay. So was it b minus 1 here? A minus 1? Okay. Well, didn't really logic my way to the answer, but got there. I mean, I was thinking it was off originally, so I had a sense that was slightly wrong, even if I didn't really think it through. Alrighty. Okay. Well, that was one of the tamer hard ones that I've done. Or at least didn't fully run into me like a brick wall. I didn't run into it like a brick wall. Okay, so that's that. Number of half operations. Low bucket count. Okay, I think that's all fine. I wonder if there was a slight optimization I could do to kind of combine ranges, combine queries into some meta query, and then do just as like a single pass on a meta query. That probably would be too hard, to be honest. This is pretty fast. I mean, this is constant time. For a given query, I'm doing two log operations to figure out where the buckets are, or which buckets are applied at the very end of the range. And then it's not like I'm doing a for loop here to even get the total ops. It's just calculate how many values are in the lowest range, how many values in the highest range, and then a fast way of doing the calculation of everything that's between. Yeah. Okay, so I think I'll keep, like, this is the notes that I think, if you understand the notes, it's just a matter of translating that to some logic that encapsulates that line of thinking. So summary, look at the notes to see the logic of how to count number of operations. Basically, for certain buckets of values, which will be differentiated, which will be whose boundaries are powers of 4. Values in those, all values, each value in those buckets have same number of operations to same number of floor x divided by 4 operations to become 0. Thus, for each query, the problem can be reformulated as how to quickly determine the number of values in each bucket, or values for the n buckets, or specifically values for n buckets, and to translate those counts to number of 4 x divided by 4 ops operations, which can be divided by 2 to get the total number of operations of defined operations, since each operation has 2 floors. So like replace not just one value but 2 values by the floor of that divided by 4. So to decompose this, 1, create an array of powers of 4. 2, within the constraint values, 1 to 10 to the 9th, I think it was. And then 2 was pre-calculate an array of full ops. Calculate full ops array, which calculates the number of 4 x divided by 4 operations needed to zero a full bucket values. So, example, how many ops for to zero bucket, that is, say between 16 and 255. So that is this thing right here. So for each bucket, there's going to be a number of values in that bucket, and then the number of values in the bucket needs to be multiplied by the number of operations that each value would be required to get from 0. Number of 4 divided by 4 operations. And then pre-calculate a prefix array to quickly sum some consecutive set of full buckets. So basically this is, for example, if you're dealing with a query, say 10 to 1000, which breaks down to, you have buckets that are 10 to 15, you have buckets that are full, 16 to 255, and you have another bucket that is, actually, let's say it's 10 to, let's say it's 3 to 1000. So you have a non-full, actually 2 to 1000. You have a bucket that's 2 to 3, you have another bucket that is 4 to 15, another bucket that is 16 to 255, another bucket that is 256 to 1000. Buckets 4 to 15, buckets 4 to 15 and 16 to 255 are full, and will have an static number of ops needed to zero them out. Buckets 2, 3, and 256,000 are kind of the side buckets, are non-full low and high buckets. Need special consideration for how many ops for them. So part 4 of this is to iterate. Well, technically slight. Actually, I don't know if you need a sort. Sorting does absolutely nothing, I guess. Yeah, sorting does absolutely nothing. So for iterate over every query, where to get the operations for that query, identify the low and high powers of 4, inclusive to that range. Count number of operation, or identify count, find count of values in the low and high buckets. Find operations, multiply those counts by corresponding number of ops, or for x divided by 4 ops. Operations to zero those out. And use prefix array to quickly add in the count of operations for full buckets between the low and high powers of 4 in that range. And then provide op for operations by 2 rounded up to get defined operations added to count, add to answer. Return answer after. Okay. Time complexity of this is going to be this should be O of n, where n is the number of queries. The work done to calculate operations needed for each query is constant, since only using kind of log commands or log function calls, and prefix array doesn't need to iterate over the values. And then space and bucket is going to be O of 1, since the prefix array and powers array are constant, or constant size. At most, like probably 16 integers in there. How many was it? Yeah, something like 16, probably less. Actually, let me go ahead and remove that sort, since that sort is definitely not necessary. And final analysis, this is going to be, yeah, the sort actually slowed it down by like a couple hundred milliseconds.